Hi, everyone. I'm Dr. Nick Ashworth. I'm from DDS. We're a part of the CDO, Chief Digital and AI Office out of the DoD. And I am here to talk to you today. Glenn's unfortunately sick, so if you're wondering where the other guy is, he is at home resting. But I'm going to be here and talk to you today about some of the AI work that we do within the DoD, as well as one of our proof of concept models, Combi. So he's a voice-controlled robot, so you just push a button and interact with him. And so, for example, hey, Combi, go ahead and introduce yourself to the crowd. Give him a sec. He's on Wi-Fi.
My name is Combi.
Okay. When I tried that 3 seconds ago, he was much more verbose, so I do apologize. But basically, what we're talking about today, DDS is unique as a DoD entity. We are mostly private sector peoples coming into the government to sort of help do tech innovation and improvements. I'm a lifetime Govy, so I'm one of the weird exceptions to the rule. But what we've been working on lately is how to use LLMs and natural language processing models in general to interface with and control physical sensors and systems. So for those of you who know robot control theory or who don't, this is the quick 100 level. One of the hard parts about controls is you have two rules that they must follow. They must be deterministic and they must be discrete. We live in the real world, so I can't spontaneously create buttons or joysticks on objects on the fly. If I did, I would have a very different form of employment. And so what that means is you either give a super simple controller, like a gamepad or something like that, or you give a super complex one, like what you see on an F-18 cockpit or something like that, but you're stuck with it. This is why home robotics has kind of struggled to take off because using a controller is hard. It's time consuming. That's why we haven't really done anything more than vacuum cleaners with them yet. However, natural language processors, and in this case we'll be focusing on LLMs, present a really interesting solution to that because you can be as complex or as simple as you want. Your controller is now able to adjust the needs of the user because language is not deterministic. Language is not discrete. We constantly create new words and phrases and induce new meaning onto them. And so it's really appealing to finally get that robot that's always been in Hollywood and Star Wars that you just talk to and it just does a complex thing. And we're really, really close to that now. The problem, however, is a lot of people have started doing research on this, and most of them are using the LLMs or the generative AI models as a marshmallow kind of structure, where you just have a GUI center and you just plug all your stuff directly into it. Motor control, just let the LLM directly handle that. Computer system thing, just let the LLM directly handle that. It'll figure it out on its own. It's better than me. And that's fine for moving rapidly. It's fine for getting stuff to the field really quickly. However, one of the fundamental problems that kind of structure has is you can't really deal with hallucinations or unwanted creativity with that, because if it's the core of your program that's going crazy, there's no way to put guardrails on it. There's no way to control it. There's no way to even really recognize it because, I don't know, maybe the dude really did want a picture of Abraham Lincoln flying on a dinosaur. It's the internet, man. People are weird. And so we came up with, or we're using Combi to prove out a framework of segmenting and isolating multiple AI models and doing a multi-model approach as opposed to a multimodal approach. So rather than doing something like the GPT-4 vision and voice control, where they're combining text and computer vision generation and recognition in one system, we're using two separate models here. We have YOLO 8 running on our camera system, and we have GPT 3.5 running on a Raspberry Pi 4. Just in case anyone asks, yes, you can do this with local running LLMs. I'm using a Pi 4 right now for a demonstration, which is a little too low power to do real-time LLM work, and so that's why we're using a cloud-based model. But you could easily swap this out to a Pi 5 or a Jetson board and do something with Llama 2 or Microsoft Phi 2. I haven't tried it out with Llama 3 yet because I just haven't had time, but I wouldn't see any reason why you couldn't do it on that either. But yeah, so we're doing all of this to sort of show off how to isolate those models, and in this case, we're using message queues as a poor man's API to force each model and system to interact over that. What that then causes is, say one of these models begins hallucinating or begins generating some unwanted creativity, they're probably going to break the API fundamentally. Like the API call will just functionally be bad, or B, the data inside that API call will be bad. And what that means now is by doing that restriction and that abstraction, you're able to use traditional programming best practices of like segmenting user input and like checking and like field validation to check for a hallucination now. It's no longer this abstract amorphous concept of like, what does it really mean when something's hallucinating or when something's on one creativity? You treat it the same way you would a bad user input, because for the model, it doesn't really care that it's talking to another AI model or a human or a like physical controller. You're doing the same checks as if you were to program it anyway. And so like that dramatically simplifies the debugging aspect of it. This also gives the advantage of everything we're doing is with dynamic context control. And so you can hot swap any of these models on the fly. Because one of the, I swear I speak English. One of the security concerns with LLMs right now, as we're talking about using them for like more than just RAGs or just document summarization, everything else, is how do I update that model? How easy is it to fix it if I find out that there's a bias in the system or that there is some weird security exploit that could be exploited? And so I'm a hacker by trade. I do RF exploitation, hack airplanes, and like getting people to do a Windows update is almost impossible, and that's free. It's simple. Microsoft does everything but break into your home and push the update button for you, and give them 5 years, and they just might do that too. But it's still really, really hard to get people to update and to get them to do patches. When you're talking about doing like custom trained LLM models for this, like look at some of the tools, some of the stuff that has recently come to market where like they trained they trained an AI model to like interact with this specific version of this specific app or to talk to like this specific system or this specific machine. Well, the moment something goes wrong, they have to retrain that entire tech stack over again, which takes time, it takes money, it takes effort. And if I can't get you to patch your home computer for a security vulnerability, which takes no time, no money, and no effort, forgive me for being incredibly doubtful that companies are going to just jump on the I'm doing it for the greater good and spend time and money and effort for a thing that we already can't to get them to do for free. So that's the two main aspects of why we're doing this. We'll do a quick demo and everything. Also, before I forget, we are in booth, where are we at? 559. We're behind the car. Combi will be here all day, so if you want to come and interact with them in person, you can. Feel free to. And then before I also jump over to the demo, as I mentioned earlier, we're with CDO, Chief Digital and AI Office. We are part of Task Force Lima, which is the DoD's effort to kind of like come up and come up with solutions and implementations of different AI and language models for the crew. And so we're part of that. And so with that said, let's get to the fun stuff. All right, so this is Combi running. This is a VNC viewer for those of you who aren't familiar with Raspberry Pi and stuff. And so this is it. And so I can do everything from, we'll do some movement commands for a start. So, hey Combi, move forward for 1 second and then turn 13 degrees. And then you'll see him do some processing. And so he did carpet lagged him down for the turn side, but like he did a super specific command. But using the same interface, I can also do something like, hey Combi, do a funny little dance for the people. And give it a sec. And so this is like, again, like I haven't changed my controller interface at all. I'm still just using my voice. We're using the same LLM, but you can dynamically generate a wide possibility of values. This is super exciting, both from like DoD and private sector, because like it introduces a ton of like functionality and like depth, or not depth, but like variability on your controller that we're normally not used to. Like DoD is very guilty of this. For those of you who remember some of like our older robot products, where it's like PackBot and some other things, where you'd have a soldier literally carrying around a Pelican case on his back. That's just the glorified Xbox controller, because like everything was so bulky and everything needed to be so bespoke and everything like that. LLMs and natural language processors have like really dramatically changed the stage to where like you can just use your voice. You can use your talk. You can use your push button radio to communicate with everything and get a wide breadth of functionality. So uh, that's kind of it. If anyone wants to come up and play with it, feel free to. Or if anyone has questions, feel free to ask them. So thank you all for coming.